In this video, we're going to look at a couple of extra practice problems with direct and inverse variation. These are going to be a little bit more complicated problems that have some joint variation. So let's start by just reading this problem. The force needed to keep a car from skidding on a curve varies inversely with the radius and jointly with the weight of the car and the square of the speed. Oh my gosh, we have so many variables. So what I'm going to do is I'm going to pause this. We are going to stop and let me kind of block off this part of the text because this part of the problem is what tells us the form of our equation. So the force needed to keep a car from skidding. So that force, that's going to be our y value, okay? To keep a car from skidding on a curve varies inversely with the radius. So we can just, how about we just use r for radius? And jointly with the weight of the car, which can be w, and the square of the speed, which we can use s. So it doesn't really matter what variables we use, but now that I've kind of defined those, let's write our equation. So the force needed to keep a car from skidding on a curve, we're going to have our k, don't forget about the k value, varies inversely with the radius, that means the radius in the denominator, and and I need to be color-coded, and jointly with the weight of the car, and the square of the speed. Okay? So hopefully you kind of saw how I set up. If it says it varies like directly with it or jointly with it, it means we're up here. Okay, in the numerator. If it varies inversely, we're down here. So we have all sorts of stuff going on in this problem. Now, we're moving on to the second part. It says that it takes 300 pounds of force to keep a 2,000 pound car from skidding on a curve that has a radius of 500 feet at 30 miles per hour. So it's just plug and play to figure out what our K value is. So it says it takes 300 pounds of force, we don't know our K value, to keep a 2,000 pound car from skidding on a curve with a radius of 500 feet and at a speed of 30 miles per hour. Now, let me do some calculator button pushes. I'm pretty much going to take this whole value and punch it into my calculator. So we get 300 equals K times 3,600. And it looks like I've kind of run out of room, so let me come up here. 300 equals K times 3,600. And let's just divide both sides of that equation by 3,600. And if I do that, I believe I should get 1/12. And that's our constant of variation. And so what we can do now is we can use that to actually answer this last question with what force will keep the same car, ooh, that's good because that tells us the weight, from skidding on a curve that has a radius of 800 feet at 60 miles per hour. So, what force, so let me just kind of write what we have. So we're trying to figure out the force. We know that our K value is 1/12. And now the weight of our car is the same. It's still a 2,000 pound car. But now it's going at 60 miles per hour. And then it says the radius is now 800 feet. Well, for now, all we got to do, we don't have to do any algebra. I'm just going to punch all that in my calculator and get our answer. And I got 750. Since we're talking about force, it looks like our force is in terms of newtons. I think it said somewhere, or 3,000 pounds of force. I guess our force is in terms of pounds. Okay, and so that is our answer. Let's do one more example. The federal government has developed the body mass index, or BMI, to determine healthy weights. A person's BMI is, now we're getting to the important stuff, is directly proportional to the weight and inversely proportional to the square of his or her height in inches. So let me kind of block off that part of text because that part of text is going to tell us the structure of our equation. Okay? So a person's BMI, what we're trying to find, we can call that Y, is directly proportional to his or her weight, which we can call W, and inversely proportional to the height, which we can call H. Sorry, that is not very neat at all. But what we got is a person's BMI, and we've got our K value, is directly proportional to the weight and inversely proportional to the square of his or her height. So this is going to be the structure of our problem. It says a 6 foot tall person, and the 6 foot is a height, but we got to be a little bit careful because I believe it says the height's in inches, right? Yeah, the height's got to be in inches. So if we do y equals k over our h, so a 6 foot tall person would be 72 inches tall. I guess I'm going to leave off the units, and that's being squared. And they weigh 177 pounds, has a BMI of 24. Now what we're going to do here is we just need to solve for K. So 72 squared, I'm going to kind of come up here where we got a little bit more room. We have 24 equals K times 177 divided by 5184. Well, if I multiply 5184 on both sides of my equation, I'm getting 124,416 equals K times 177, and then I'm going to divide by that 177 on each side of my equation. And I'm getting kind of a gross K value, so I'm just going to round it, 702.9. Okay. Now that I have that K value, we can actually solve our equation. We have y equals K times W all over H squared. And let's just plug in these values from this last part of the problem. It says, find the BMI to the nearest whole number of a person whose weight is 130 and whose height is 66. So we're trying to find the BMI, but we're given that the weight is 130 and that the height is 66. They give that to us in terms of inches, so that's good. So I'm just going to punch all this into the calculator. So we end up with y equals roughly 20.98. Oh, it says to the nearest whole number, doesn't it? So let's just take that, ran that on back into a 21 would be their BMI.